Are you guys watching the recordings? Anybody? Are you guys watching the recordings? If you are having any doubts, then yes. Okay, shall we start? Tell me yes or no. Just thumbs up if we are good to go. If we are good to start. Okay, cool, cool, cool. 12 people have joined. I don't know why people are not joining, but yeah, let's just start. Okay, we can't just wait for someone. Let them see the recordings. I hope my audio is clear and my visual is clear. If anybody has any issue over it, just tell me so that I can know. Okay, and I'm also recording the classes so that yeah, I'm also recording the classes so that I can later on share the screen. Okay, cool. So I'll go with the next question. Okay, yesterday's next question. I'll go with the. Uh, Anybody having any problem? Just ask me. Okay. All right. So yesterday's question. Tell me up to what point we are done. So sum of a digits done, product of a number done. We are left with number is prime remaining, divisor remaining, sum of all divisor remaining, check all the number is perfect, largest number in a number, smallest number digit in a number contains 0, we are done, even done, odd done, last digit done, print the digits of a number one by one done, find the square of a digits done. Okay, check whether a number is harshad, not done, check whether a number is strong, not done. Okay, cool. So I'll start with the easier one. Okay, so find the largest number in a digit in the number, find the smallest number in the digit in a number. Okay, I'll start with this. All right, so find a largest number in a digit in a number. Okay, let me write down this question. I hope is everyone is able to see. So now my question is quite simple. My question is a is given 1 2 3 4. Tell me what should be the output. Simple. What should be the output? Tell me. What should be the output? Output, guys. Output for this. Find the largest digit in a number. 4. Exactly. If I write something like this, then output should be 5. Clear? So what I'll do, first step, tell me first step. Yesterday, from yesterday's class, what do you understand? First step, what is the first step? What is the first step? What is the first step? Yesterday, what we do? Yesterday, what we did? Guys, tell me what I should do. First step, what is the first step? Tell me. Yesterday, all the no. What is that call? What is that call? While a not equal to 0. What is that call? Condition. No, no, no. What we are doing, actually, what we are doing, we are, what is it called? Iteration. Iteration. All we have to do is one by one iterate. Until and unless you iterate, you can't do anything. First, get that in your mind. Whenever you are solving number problem, first iterate according to the question. Okay, here I need to find the largest number. Largest number means among one largest number will be there. Means what? You need to iterate. Don't forget that first step is iteration. So let me write it as n so that you can understand. Okay, so what I'll do is while n not equal to 0, I'll be iterating. Simple. And here I need to find one max number, right? Max number, let's say 0 here. Okay, I'm keeping the minimum number so that I can find the maximum number. Just a value, simple value. Okay, while n not equal to 0, what I'll do, I'll try to find a remainder. How I'll try to find a remainder? N modulo 10. Okay, I'll try to find a remainder. Now In each and every time I find remainder, what I'll do, I'll try to compare with if. Everyone observe now, iteration is going on. Now in the middle of the iteration I have to check whether the number is greater than the last one. Okay, so for example I will check if remainder is greater than max. Are you understanding? Tell me yes or no. Means the remainder in the first go, remainder is 4. Okay, so the 4, is it greater than 0? Yes, 4 is greater than 0. So what we do, we update the max with remainder. Tell me, are you understanding or not? So every time we go, we will check is remainder greater than maximum. Means maximum first is 0, right? So is 4 greater than 0? Yes. So max will be now updated as 4. Okay, next time remainder will be 3. Is 3 greater than 4? No, don't update. Is 2 greater than 4? No. Is 1 greater than 4? No. Is 5 greater than 4? Yes, again update. Okay, at the end you just print out max. Okay, you can name anything, does not matter. So if I run this, now output will be okay. One thing I'm missing, can you tell me what one thing I'm missing? One thing I have missed. It will run forever. Why it will run forever? Can you tell me? Why it will run forever? Anybody? I am not decrementing. If I don't decrement, if I am not decrementing, what it will do? It will stay same. So if it will stay same, it will run forever the same value. So I have to decrement. This line is decrement. Okay, here I am checking not equal to 0. Here I am finding the value, and here I am decrementing. In the middle I am just checking if remainder is greater than max, then max equal to remainder. Just update, that's it. At the end print max. Tell me, is it clear everyone? Anybody, any doubt? Same formula again, same formula, nothing, no change. Okay, I just want you to go step by step. First number game. First be clear with number game. After that go with array. After that go with strings. Okay, one by one we'll go with. So the first one is done. Maximum. Now minimum. Tell me what to change. I just have to change one thing. Just one thing I have to change. Can you tell me what to change?
Remainder less than.
Exactly. You just have to change remainder less than. So this time you are checking less than. But if you are making less than, will it give me an answer? Tell me, will it be a correct answer? No. Why?
Max is equal to 0.
Yes, so it is already 0 and you are trying to find minimum than that, so it is not gonna do minimum. So what you have to change, you have to change something called uh, we I think we name it as infinite, something like this. Okay, I forgot then the syntax. I'll just search it. Infinite, how to give infinite? I have to give the biggest number, right? So yeah, I guess this is the case. This is the same case. Let me run. Yeah, this will work. This is the case. Float, quotation, infinite. In every language it is different. In Python it is float infinite. You have to give the largest number. Simple. You have to take the largest number, and largest number is defined by this float inf, and you have to keep it as minimum. Why? Because you are trying to find the minimum value, right? So minimum value. And if you have to take the smallest number, you have to take here minus. Okay, minus. See, minus infinity, it is already smallest. There is no smallest number than this. So if you have to take the largest number, float infinity, and then you have to take 1. Answer is 1. Why? Because it is the smallest number. Is everyone clear? Tell me yes or no. Anybody, any doubt? Anybody, any doubt? 2 questions are done already. Okay, 2 questions are done. Tell me any doubt, anyone? Anybody, any doubt? No, and everyone is clear. Just thumbs up if you are all clear. Largest and smallest. All of you. I said all of you. Are you guys sleeping? All you need to do is just react. Just button. Here I am doing all the talking. Okay. You guys just need to press the button. That's it. Okay. Don't be so lazy. Okay. So done. We are done with the two question. Next we'll go to we are done with largest, we are done with smallest. So I'll just write down this question. Okay, we are done with this, we are done with the smallest. Okay, we are done with the smallest. Now what we'll do is we can go with summer divisor, number, perfect number. Okay, we'll all this touch all this little later. Okay, little later. First let's contain 0 done, even number done, odd number done, last digit done, print dozen on by one by one done, sum of squares done, harshad-number, sum of a digits. Okay, then I think we can start this. Okay, so now next I'll go with the question called palindrome done, counts of a digit done, sum of a done, Armstrong number. Okay, Armstrong number. See, everybody observe now what is Armstrong number. See, Armstrong number 153 is an Armstrong number. Why? Because tell me, in 153 how many digits are there? First of all, how many digits? 3, right? Total number is 3. So what you do, 1 cube plus 3 cube plus 3 cube, 1 cube plus 5 cube plus 3 cube. So it will again become 153. So if it becomes, it is a Armstrong number. So another example is let's say another example 1634 is an Armstrong number. Why? Total number is 4. 1 to the power 4 plus 6 to the power 4 plus 3 to the power 4 plus 4 to the power 4. If you do it total, it is again 1634. Am I clear? Am I clear? Tell me yes. So basically you have to take all the count to the power, each and every number to the power count. If it is equal, then it is Armstrong. If it is not, then it is not Armstrong. So let me just save the question here, check whether a number is Armstrong or not. Let's do it. Okay, so what we'll do now is we'll take one number, for example 153. Tell me, 153 is Armstrong or not? Yes or no? Yes. So first our goal is to find the count of a digits. So there are two ways to count. Tell me, what are two ways to count? I told you yesterday itself. There are two ways to count. Yes, doing the iteration or using the string. So I'll just keep it short. Okay, I'll just keep it short. So I'll use it using string. I'll just convert it, and then I'll take the length of this. Simple, 2 lines. Length of s, so that I can find the length. So if I print L, see, if I print L, let me for now comment it out. See, what is the length? Length is 3. Clear? If it is 4 5 5, length is 5. Understanding, everyone? Tell me. So there are two ways. One way is iteration, one way is string. I am just using the shorter one. So first I have converted to string, and then I am changing it to length. Okay, I am just finding the length, because number you cannot find the length. Number is non-iterable. String you can find the length. So string, I am finding the length and printing the L. L is nothing but 3. Okay, so now what I should do, I'll just use this N. So N is 153, S is this string format. Okay, so what I'll do, I'll take one by one value. Now I have to store it, right? I have to store it. So do you remember the palindrome yesterday? If we do this, it will remove the original version, right? So I'll keep it in temp. So I'll keep it in temp so that we can compare. At the end we need to compare 153 and the answer, right? So what we'll do, let's say answer is 0 for now, at the end we'll compare temp and the answer. Okay, simple. That's why I've kept temp and answer. Now what I'll do, remainder one by one I'll find, and I'll just update the answer equal to previous answer plus remainder to the power. To the power, you can just write it this way, to the power total count is nothing but L. Okay, now you just keep going on, reduce the number one by one, and at the end you check if answer equal to temp, means it is print Armstrong, else print not Armstrong. Okay, so it is not Armstrong. Wait, something is wrong here. Let me just 153 should be Armstrong, right? So answer, let me just print answer here. Answer, let's see what is the answer. Answer is 4. Okay, answer is 4 means it is wrong. So what is the wrong here? So I think this is wrong. So what we should do is, it is doing XOR. So what we should do, we should do power. Power is nothing but 2 star. Okay, now it will show Armstrong. See, Armstrong. Okay, power. You can do like this power also, and you can also use function math.pow. Also you can use math.pow. But if you want to do in shortcut, just use 2 star and it will give you a power. Okay, everyone now check. It is quite simple, it is not very difficult. Okay, I have just found out the length, so that I have to do the power right here. Power, it is similar like square sum. There you are just doing square, here you are just in to the power L. L is nothing but count, total count of a digits. So I'm just counting here, it is n, just like palindrome, and it is while n not equal to 0, what you do, you do the same thing again and again, and at the end you check whether temp and answer are equal. If it is equal, Armstrong. If not, not Armstrong. Check it everyone, tell me if any doubt is there. Check it, check for 1-2 minutes everyone, tell me if any doubt is there. If any doubt is there, ask me. Any doubt? No doubt, anybody? Okay, we are done with 3 questions, right? No doubt, anybody? No doubt at all? Yeah, I wonder. How will you have doubts? Who is teaching? How will you have doubts when I'm teaching? Yes. Now somebody will be, sir, doubt, sir. What is this, sir? Don't ask me doubt now. Okay. These are quite simple things. Okay, you just need to open up your mind. That's it. You just don't need to be in your own imaginary world. If you are in your own imaginary world, you won't understand. But if you are having presence of mind, then you will understand this. Simple presence of mind. Simple. Keep your mind always in present, not in past or future. Okay, just keep in present, you will understand for sure. Okay, so I'm done with this 3rd question. Let's go to the next question. So this is one type of question. Okay, these are all whatever yesterday we saw 11 question, 12, 13, 14. Today 14 questions are all of same type. Understanding everyone? Just keep it in your mind. Okay, this is one type of question. This is all one type of question. Now I'll be going to different type of question, number question. Okay, now I'll be going to different type of question. So everyone, you can just check it out. If you are having any doubt, you can check out the recordings. Okay, I'll now remove. Can I remove? Tell me yes or no. Just thumbs up if I can remove. Okay, cool. Alright, so I'm removing. Let's go to next. Okay, let's go to next question. So it is done. Now next question is whether it is prime, print all divisor, check all the sum of a divisor, perfect number. Okay, cool. So I'll first start with divisor. After that we'll do prime. Okay, so I'll start with divisor. Do you know what do you mean by divisor, guys? Divisor, let's say 6. Tell me what are the divisor of 6. Output, what should output be? Divisor of 6. Guys, what are the divisor of 6? Tell me. Anybody, what is the divisor of 6? Simple question I am asking. It is, kids can also answer this.
1, 2, 3,
1, 2, 3,
and 6.
and 6. How did you find out? How did you find out?
Basically, if we divide by those numbers, we get a remainder.
Yes, exactly. How smart you are. Who is this? Who is this speaking? Who is this speaking? Yamuna. Okay. Why others are not replying? I'm asking you a simple question. What is the divisor? You all forgot all this? All this simple question. 6 divisor is 1, 2, 3, 6. Okay, so we need to print all this. Let's start with the from the very basic. Okay, I'm doing all this just to make you understand, okay, how programming works. I know all of this, you know, simple maths, but simple maths, how to put it in a programming, I'm just making you do. This is last day of last day of maths, number question. After that we'll move into array. Okay, so step by step we are moving. So what I'll do is, see, this time let's say n equal to 6. N is given 6. Now when n is given 6, you need to print all the divisor. Means this time you need to run a iteration, or you need to run a loop. So basically we need to run a loop. From where to where we need to run a loop? Tell me. From where to where we need to run a loop? 1 to n. So do we know how many times to run this time? Tell me yes or no. Yes. So which one to use, while loop or for loop? For loop, exactly. We are using while loop because at that time we didn't know how many times to run, so we are using those while condition. But this time we know how many times to run. We have to run from 1 to n. Okay, so I'll use for loop. So I am sure you remember this. For I in range, from where to where? From 1 to n plus 1. Why n plus 1? Tell me, can anybody tell me why n plus 1? Why not n? Why not n?
Because the last number is n minus 1. That's the reason we are putting n plus 1.
Yes, exactly, because for loop will always run up to n minus 1. So in order to reach 6, you have to go till 7. You have to write a 7, that's why, so that it goes till 6. Okay, so now we are running from 1, 2, 3, 4, 5, 6. Now what you have to do? You have to check one condition. What condition? During running, during you run the loop, what you need to do? You just need to check this n. N is what? 6. This n modulo 1 by 1 numbers. What is 1 by 1 number? It is nothing but I. I is nothing but 1, 2, 3, 4, 5, 6. So 1 by 1 it will check 6 divided by I, 6 divided by 1, 6 divided by 2, 6 divided by 3. So if the remainder is 0, that means it is divisible. So 6 divided by 1, it is 0. So it is print I. Okay, every time it is divisible, you print I. Simple, done, program is done. 1, 2, 3, 6. If it is not divisible, don't print. Simple. Clear, everyone? Are you, see, the main thing here to understand is why we are using for loop. Why not while loop? While loop also you can use, no issue. I'm not telling you can't use, but there is no use of while loop here, because you already know how to run, how many times to run. Understanding the difference between these two questions? Are you understanding difference between that kind of question and this kind of question? This is different. Here we don't need to iterate each and every value. There we need to iterate each and every value. So that is first type of question. This is second type of question. Understand this very carefully in your mind. All those 15 16 questions that we have solved, those are one type. There you need to iterate numbers. Here you don't need to iterate. Here you just need to iterate from let's say one number to n. N means the given number. If it is 6, you just have to go till 6. If it is 200, you have to go from 1 to 200. Understanding? You don't have to iterate one by one. I hope you are getting the clear cut idea of how this works. Okay, simple. Now this is done, divisor is done. Okay, divisor is done. Now let's go to prime. Will do. Okay, sum of all divisor. Okay, let's do this, sum of all divisor. So next question is sum of all divisor means what? This sum we need to sum it. Okay, for example 1 plus 2 plus 3 plus 6. So what we can do, instead of printing, what I'll do, I'll just sum it. How do I do? Sum equal to sum plus I. Okay, at the end I'll just print sum. Answer will be 6 plus 3 9, 9 plus 2 11, 11 plus 1 12. Answer is 12. Done. Simple question. Don't put too much, these are not rocket science. These are simple question. Just open up your mind. If you have a presence of mind, you can understand, okay, this is what is happening. Okay, done. I hope this you are clear with. Earlier we were printing, now we are just doing the sum. At last we are printing the sum. Clear? Now next let's go with the next question. This two question, print all divisor done, print sum of divisor done. Now let's check whether a number is perfect or not. Okay, because all these are we are done, right? Largest number done, smallest number done, contains 0 done, even number done, odd number done, last digit done, this one by one done, square sum done. Okay, just harshad and strong is remaining. We'll check that, but before that what we'll do, we'll do one question here. What is remaining? Perfect number. So what do you mean by perfect number? Everybody understand this, very important. Perfect number, no, not this. Perfect number. Just show you an example so that you understand what is perfect number. Okay, so see, perfect number is 6 is a perfect number. Why? See, the divisor, what are the divisor? 1 plus 2 plus 3 plus 6 also is divisor, but don't take the number itself. You have to leave the 6. So leaving the 6, your sum is 3 plus 2 plus 1. What is the sum? Sum is 6. So 6 sum is equal to the number itself. If it is number itself, then it is a perfect number. Okay, I'll show you. 6 is a perfect number. Okay, 28 is a perfect number. Why 28 is a perfect number? Everybody observe. 1 2 4 7 14 and 28 itself, but you don't have to take 28 number. You just have to sum all this and it becomes 28. So if it becomes 28, it is perfect number. Are you understanding? Tell me yes or no. Simple question, right? Not very difficult. So what we'll do here, tell me. Simple, tell me. Very for loop, where to where run? Yeah, where to where? Exactly, 1 to n. You don't need to run till n plus 1. Okay, now sum, and you just have to check if sum equal to n. Then what you do? You print what? You print perfect or true, like that also you can, else not perfect. Okay, not perfect. So let's say 6 is a perfect, right? 6 is a perfect number. 28 is a perfect number. Okay, but if you check any other number like 8 is not perfect. So not perfect. Tell me, are you getting this? Everyone got it? Just thumbs up if you have got it. This are quite simple. I am showing you, all those similar types of question. I'm not mixing up the question. First type is done. Second type is this. Okay, second type is this, where we are just, according to the question, we are just changing few things. That's it. According to the question, not much change. We are just doing few changes. Okay, so we are done with perfect number also. So I'll just copy the question. Perfect number. Check whether the number is perfect or not. Okay, perfect or not, done, right? Okay, next let's go to next question. It is done, divisor done, print all the number, print all the number divisor of a number, done. Okay, largest number, done. So one thing is remaining, prime. Okay, prime. This is quite little confusing. Many people make mistake over here. I'll be look at it carefully. Okay, carefully look at it this time. Don't try to mess. Okay, don't try to mug up something. Just try to understand. I'll be sharing the screen. You everyone try to understand. Okay, I'll be telling you the most efficient way. Okay, efficient way. Just focus on the screen, everyone. Prime number, last one, and then we are left with how many question? 2 3 question, I guess. So 2 question we are left with after prime number. So after prime number we are just left with Harshad and Strong. Okay, after that we are done. So we'll just see for prime number. I'm just sharing my screen, just a second. Why I'm not able to share my screen, just a second. It is not sharing. Let me just directly explain you. Okay, using the screen, let me just explain you. Okay, try to understand, everyone. Try to understand. It's not, I'm not able to. Okay, so I'll try to explain you over here. So see, prime number. Okay, prime number, when it comes, let's say 7. Okay, 7, is it prime number? Tell me. 7, is it prime number?
Yes.
Why it is prime number? Why it is prime number? 1 and 7. So if you check 1 2 3 4 5 6 7, no other number is divisible. Basically just 1 and 7. Okay, so if you see, let's say 6, is it prime? No, because it is 1 and 6 are there. Okay, fine, no problem with 1 and 6, but it is also divisible with 2 3. Okay, if any one is more divisible, then it is done. Okay, so basically I have to run one loop from where to where? Tell me, in order to check whether it is prime. Tell me from where to where I have to run a loop. For example, let's say 7. From where to where I have to run a loop? Tell me, anybody. 2 to number. Why exactly? Tell me. Yes, you are correct. So why I am running till from 2? Tell me, why not 1? One number are divisible by everything, whether it is prime or not prime, it is divisible, right? There's no differentiation. So what we do, we check it from 2, because we need to find prime, right? If we want to find prime, we have to check from 2. If you are checking from 1, you cannot find, because 1 is both divisible by any number. Even number itself is divisible by any number. So what we are doing, we are running till n minus 1. Is everyone clear? Tell me. The range, the most important thing is range. If you are understanding the range, you can play with it. Don't write n plus 1. If you are writing n plus 1, is it correct? Tell me yes or no. If you are writing n plus 1, it is wrong. You just have to write n. Why? So that n minus 1 it will run. If you are writing 7, it will run till 6. Okay. Now you have to check if n means 7, is it divisible by any of the number. If it is divisible by any of the number, tell me what to print. Tell me what to print, guys. Prime. Yes, because prime or not prime? When it becomes prime? When yes, yes, and when it is not divisible by any of this number, then only it becomes prime. But when it is divisible by any of this number, then what it becomes? Not prime. Exactly, not prime, because it is divisible, right? 6 example, 6 is divisible by 2. Yes, 6 is divisible by 2, so not prime. After not prime, what you should do, tell me. Do you need to check further? If you found 1, do you need to check for further? No. Yes, break. Exactly. If you don't break, it will check again and again, and it will print again and again not prime. I don't want to not prime again and again. Okay. So if you don't break, see, everyone observe. If you don't break, let's say 6. So what it will do for 6? For 6, it will print not prime, not prime. I don't want not prime, not prime. I just want, if one time it is 2, 6 divided by 2 is divisible. So what I'll do, I'll just break. That is the use of break. Break means once you got it, break. Break. Done. Okay. Now if you are not finding anything, for example 7, anything is not divisible, but because why? It is prime. It is prime, right? Nothing is printing. So what we should print? Tell me. What we should print for this 7? It is not printing not prime. What it should print? It should print yes, else. Do you remember this else? Yesterday I used while with else. Here I am using for with else. When this else runs, tell me. I to explain you yesterday. When this else runs, this is not if else. Don't mistake it with this if. No, this is this else with is with this for. Okay. When this else runs, tell me. When this else runs, no. When this else runs, tell me. See, everyone observe. Everyone observe. If I could show you. See, think it, everybody think it like a engineering college. This is your engineering college loop, okay? 4 years, let's say. You start from 2, you go till n. Now, if you do something mischievous in between, and if you are breaking it, means if you are dropping out from the college, will you get the degree? Tell me. Will you get the degree? Yes or no? No. That means you will not get this. You will not get the last one. Basically because you are breaking it in between. But if you are not breaking in between, if this condition is not true at all, then what you do? At the end you will get the degree. Think it as a degree. When it is not breaking, then only this will run. If it is breaking in between, this will not run, because you are not completing your degree, right? So answer is not prime. Not prime. Why? Because it is not breaking. If it is breaking, it will come out of the loop. It will not run else also. But if it is not, if it is breaking, means prime. So for example 6 means prime. 6 means not prime. See, 6 means not prime because it is not breaking at all, right? It is not breaking. So no, it is, see, it is prime here. Yes. 6 is not prime. Why? Because it is breaking in between. It is breaking, and 7 is not prime. 7 is not 7 is prime. Why 7 is prime? Because it is not breaking in between. Because 7 has no divisor. So no divisor means no break. No break means this will run. Am I clear? Tell me yes or no. Anybody any doubt? Anybody any doubt? This else is with for, okay, else is not with if. In Python only you can give for and else, while and else. So when else will run? When it is not breaking in between. Think it as a certificate. You get certificate when you are not breaking in between. When you are breaking in between, you won't get any certificate. Yeah, after the full execution of for loop, after that it runs else. Done. Simple. If it is breaking in between, done. Else will not run. Else will not run. Is everybody clear? Tell me yes or no. We don't have much time. Okay, let's check. For that let's check. Okay, good point. 2, is it a prime number? Yes, 2 is. See. Here it is starting with 2, but here you are writing and is also 2. And is means 2 means and is minus 1. 2 minus 1 is what? 1. So you are starting with 2 and ending with 1. Is it possible? Tell me. No, it is not possible. So it will not go inside this for loop. Directly it will come else. That's why this is valid even. Because you are starting from 2 and ending at 1. How you are going to start at 2 and end at 1? It is not possible. And you are just running a loop in a positive manner, not negative manner. Okay, done. Is everybody clear? Just thumbs up if it is clear. We can move to the next question. Everybody just thumbs up if it is clear. Just practice this once, okay? Practice this once, or else you will be forgetting. Okay. Now one more thing I'll try to do here. See, if anybody wants to this question, if you want to make more efficient means, see, if it is 1 crore, big number, let's say, then how many times you need to run this? You need to run this till all these numbers, understanding, from 2. But what math says, let's say 18. What math says? See, 18, tell me the divisor of 18, guys. It is nothing but 1 into 18, 2 into 9, 3 into 6, and then what else? 6 into 3, 9 into 2, 18 into 1. Can you see some pattern? Tell me what pattern you can see here. Can you see some pattern? Tell me yes or no. Can anybody see some pattern here? Can anybody see the pattern here in this? See, it will go till half. So till 1 2 3 it is fine, but after that it is repeating. Can you see that? 3 into 6, 6 into 3, 2 into 9, 9 into 2, 1 into 18, 18 into 1. This is a formula, math. It is nothing but math. After you go till half, after that half it will just repeat again. So let's say 1 to 18 half is nothing but 9, right? So till 9 1 2 3 till here it is repeating just up to 3 into 6, 6 into 3. Yeah, it is just repeating up to 5. Okay, till 5 it is growing, but after 5 it is decrementing. Understanding? After that it is just repeating, nothing but repeating. So what you can say? Can you say it as, you just have to check till half. If in the half, if any number is there divisible, then it will be prime. You don't need to check for the half. If there is nothing in the half, in the other half there will be nothing. So for example, in the first half there is nothing, then second half there will be nothing. Understanding? If first half exists, then only second half exists. So that we can find out by just going into half. You don't need to go full. Understanding everyone? Understanding everyone? Understanding everyone? Any doubt? Ask me. Anybody? Any doubt? Anybody? Any doubt? It is simple maths. If till half it is there, after that half it will repeat. So 3 into 6, 6 into 3. So if 3 does not exist, 6 will not exist. Divisor will not be there. If 2 into 9 is there, then only 9 into 2 is there. If 2 is not there, 9 will not be there. Understanding everyone? Tell me yes or no. If it is done, just thumbs up. If you are understood, it is pure maths. Nothing is there. Pure maths. So if you have understood, I'll see. I'll just run this and I'll show you it is not prime. 18 is not prime. Why? Because many divisor are there. Let's say 20, 20, 31. 31 is prime, I guess. Yes, 31 is prime. So check it. 31 is prime. Okay. 31 is prime. Also, you can reduce this not just up to half. You can reduce it to root actually. Root. So for example, 18. What is 18 root? 4 root is 2. 9 root is 3. What is 18 root? 16 root is 4. 16 root is 4. What is 18 root then? 18 root. Let's say 18 root. What is 18 root? 18 root is nothing but 4.2. 3 root 2. See, 4 into 4 is 16. 16 root is 4. 18 root will be little more. So it is nothing but 4.24. Okay. So how we can find out root here? We can just find out root by square root, I guess. How do you find root in Python? Let's say I forgot the syntax. Operator. Okay. Square sqrt. So I can just find out here math.sqrt of n. Okay. So it will just run till 4. So I can find out. Okay, I have to import. Now see, I am using math, right? Import math. Math is a library where all the functions are there. Interpreted as an integer. Cannot object, float object. Okay, it is float. So I have to. It is 4.24, right? I have to make it as a integer. So I am making it integer. So not prime. Okay, not prime. Why? Because 2 is there. It is running till 4. See, 18. What is 18 root? 4.2. That is pure maths. Pure maths it is. Okay, you don't need to run till 18. So earlier you were running till 17, right? Till 17 means it is too many times you are checking. You don't need to check. What math says is you just check till root. What is the root of 18? 18 root is 4. 4.2 something. So you just run till 3. So if you can run till 3, you will find out whether it is prime or not prime. Are you understanding? Tell me. Is everyone understood? Just thumbs up if you have understood. All these are ways to make efficient. Efficient means I don't need to run too many times. Understanding? I don't need to run it again and again and again. I just need to run till mathematical. What is the exact mathematical process? I just need to know that. If there is any value, we will find out before root. If after root, it is just repetition. Just repetition. 3 into 6, 6 into 3. It is repetition. 2 into 9, 9 into 2. It is repetition. And root is 4 here. After root, it repeats. Okay. 5. 25. What is 25 root? It is 5. Okay. So you just have to check till 5. If there is no root till 5, so you can also write, see, for 25, you can check here if it is valid or not. It is not prime. It is saying prime. So one mistake is there, that you just do +1. Otherwise, it is not taking the number itself. So it is not prime. You just do +1. Because see, 25 square root is 5, right? So if you write 5 in the for loop, it runs till 4. So you just have to write till 5. That's it. For running till 5, you just have to write +1. Am I clear? Tell me yes or no. If clear, thumbs up, so that we can move to the next question. These are simple. Okay, these are simple. These are basic maths. Basic maths. Up to what point I should run? Up to square root +1, so that it runs till square root. Yes. Yes. Okay. 8 is what? Tell me, prime or not prime? Prime or not prime? Not prime. Not prime. Tell me any other number if you are having confusion. Okay, it will run. It will run. It is valid question. Okay, it's not my invention. I have also learned this somewhere. So I am not telling all this. It is a pure maths that it says till run till up to root, not root plus 1. Why I am doing? Because of for loop, just for loop. But actually you have to run till root. So for example 5, if 25 is there, you just have to run till 5. You have to include 5. So I am running till 6. That's it. 6 if you run, it will include 5. And if you can check from 2 to 5, you will get 5. 5 is divisible. That means break, not prime. Simple. Clear everyone? Tell me yes or no. Thumbs up if you are clear. Okay, done. So if you are done, we'll move to the next question. I don't know why it is not working today. I'll just try to change the Wi-Fi. Okay, can you guys hear me? Tell me, is there any disturbance in the Wi-Fi? No, right? No, right? Yes. Same Wi-Fi now. Tell me, can you guys hear me? Can you guys hear me? Yes or no? Okay, cool. So now I'll move to the next part. Okay, next part. Prime is done, divisor is done, all divisor is done, right? 3 questions are done. What questions are left now? Prime is done, divisor is done, perfect is done. So prime is done, divisor is done, perfect. Sum of all divisor done, right? Sum of all divisor done. Okay, so perfect number done, largest done, smallest done, count done, even number done, odd number done, last number, last digit sum done, harshad and strong number done. These two are left, right? Tell me. Yesterday 11 done, 12, 13, 14, 15, 16, 17, 18. 18 are done, 2 are left. Just 2 are left. Okay, so we'll first check out with this harshad number. What is harshad number? First check out this harshad number, everyone check out harshad number. So what is harshad number? Everyone try to understand. Okay, try to understand. Let's take a number 156. Sum of its digits are 1 plus 5 plus 6. It is 12. Now 156 has to be divisible by 12. Okay, so if since 156 is divisible by 12 without any remainders, 156 is a harshad number. Very interesting. Simple. Tell me, are you understanding? First 156, find the sum. What is the sum? 12. And now you have to check 156, is it divisible by the sum? If it is divisible, it is harshad. Understanding? Understanding. 132 is harshad. How? 1 plus 3 plus 2, it is 6, right? 132 is divisible by 6, so it is harshad. Understanding? Tell me yes or no. Tell me yes or no. Everyone just thumbs up if you are understanding. Any doubt, anyone? Harshad, take a number, sum it. So 132 sum is 2 plus 3 plus 1, 6. So divide the number by the original number and then find whether it is divisible. Yes, divisible means harshad. It is, if it is not divisible, not harshad. Clear? Let me just write the program. Very simple, very simple. Okay, check whether the number is harshad or not. So I'll just copy this question and I'll try to write it here. Okay, so what I'll do is prime number, guys. Prime number, make sure you are understanding. Okay, what I'll do, 132, right? 132 is a harshad number, right? So what I'll do, while n not equal to 0, what should I do? I should run 1 by 1. So first I should take the sum. Sum means sum is equal to, I'll do some shortcut here, n modulo 10. Directly I'm taking the remainder and I'm doing sum equal to sum plus n modulo 10. So this is nothing but remainder I'm summing up 1 by 1. and n equal to n modulo 10. Are you understanding this? By now you should understand this. One line I am just missing, remainder equal to n modulo 10, right? I am just directly summing up. Okay, so if I print the sum, tell me what will be the sum. Here sum equal to 0 is remaining. Tell me what will be the sum. Sum is nothing but 6, right? So sum is 6. So now I have to check if n, now n is what? N is what? 0, right? So I have to write temp equal to n. Now if sum, if temp original number modulo sum equal to 0, if it is divisible, what should I do? Print harshad, else not harshad. 132 is harshad. 150 what? 156, right? 156 is also an harshad. 156 is an harshad. But if you check any other number, 144, let's say, it's not an harshad most probably. It is harshad, is it? 448, 8 plus 1 is 9. So is 144 divisible by 9? Is it divisible? 144 divided by 9. Is it? Yes, right? Okay. So 143, let's see. Should not be harshad. Not harshad. Yeah. So it works. Tell me understood or not? Simple, right? Simple. See, now are you able to visualize any question given? Are you able to visualize on numbers? Tell me. That is what I'm talking about. See, if you do it alone, you will be like, okay, I'm doing it, but I'm not trying to understand the pattern. Why? So see, now I have done around 18 question on number itself. Okay, 2 patterns are there. One is the prime number pattern, divisor pattern. One is reverse pattern. In reverse pattern we have solved around 12 question, 12, 13, 14 question. In divisor pattern we have done for 5 to 6 questions. So now you are clear with, okay, if any question comes, I can understand what to use, the first pattern or the second pattern. You just have to identify. Okay, last question, let's solve it. Last question, strong number. A number equal to the sum of the factorial is a strong number. Okay, happy number is also there. That is little tough, we'll do it little later. Okay, not now. So strong number, what is strong number? 145. So 1 factorial plus 4 factorial plus 5 factorial is 145. Understanding, everyone? Tell me. Each and every number factorial you do, sum it, it should be the original number. If it is original number, it is strong number. Clear with the question? Thumbs up, guys. Okay, this is very simple question, not a very tough one. Okay, don't think too much. So let me do the last question. Okay, so see, 145 is a factorial. So what I can do is, see, I have to find factorial of each and every number, right? So what I'll do first is I'll make a function. Why I'm making function? Can anybody tell me why should I make function? Why should I make function? Tell me, everyone. Why should I make function? Making function is a good choice here. Tell me why. Why? Tell me fast. Time is not there much. Yes, exactly. So see, basically we have to do each and every number factorial, right? Each and every number. So it's better to just call each and every number and call the function. That's it. So what I'll do, I'll write def fun. Okay, def fun is a function. Okay, let's say factorial, fact. Okay, factorial, and in this function I'll be writing the function and I'll be returning the answer. So see, how do I find a factorial, guys? How do I find a factorial? I'll be writing one answer equal to 1. Okay, answer equal to 1. It will always be 1. It will not be 0, because 1 into 1 is 1. 2, if you write 2 into 1 into 2. Okay, so for I in range, where to where? Tell me, where to where? I can write it easily in recursion also, but let me not use recursion for now. From 1 to number itself, number plus 1. Okay, so if it is 4, 1 into 2 into 3 into 4, simple. So what you do, answer equal to answer into I. Okay, likewise you will be getting the answer, and here you are returning the answer. What is the answer returned? Return answer. What do you understand from this? What do you understand from this? Tell me. Are you understanding this? In the first class I told you about fact, function. Function means what? You pass one number, it will give me an answer. Okay, so here I'm just finding the answer. So here check it out. I'll remove this for now. For now uh, I'll just comment it. See, if I give fact of 4, tell me the output of fact of 4. So let me print it also, so that I can print it. Okay, I have explained all this in the first class itself. So tell me the output, guys. Tell me the output. What is 4 factorial? 24. So it will be, answer will be 24. Okay, if it is 5, tell me the output. Answer is 120. Clear. This is very simple. If you see what I am doing, I am running a range from 1 to n plus 1, so that it runs till that number, and answer is 1, right? So each and every number I am multiplying it. 1 into 2, 2 into 1. Okay, 1 into 2 is 2. Now answer is 2. Now next will be 2 into 3, answer is 6. Now 6 into 4, 6 4s are 24. Understood everyone? Tell me yes or no, and thumbs up everyone. Thumbs up. You do practice once. If you don't practice, you will forget, I'm telling you. So this is fun factorial. Okay, this is factorial. So now what we need to do, we need to check one number. Okay, one number. Temp is what? Original number. Sum is the sum of all the factorials. Yes. So now what we need to do, we need to take one number. Okay, so I'll write here remainder equal to this value, remainder equal to this value. Yes, understanding? Now what you do, this remainder, what you do, you use a fact of remainder. Understanding? Fact of factorial of that value, you sum it in the sum. Understanding? Now one by one you do, and at the end you divide it one by one. So if temp is equal to, if temp means that original value, if it is equal to sum, then it is strong, right? Strong number, else not strong. Not strong. Okay, so 145 is a strong number, right? So answer is strong number. Okay, if I do 146, it might not be strong number, so answer is not strong. Clear? So it is a simple program. Everybody just observe it for 2 minutes. We are almost done. 2 minutes. Anybody any doubt, ask me. Anybody any doubt? See, this is the same pattern we are doing. The only change here is we have done is function. So we are calling this function again and again here. Tell me, anybody any doubt? Anybody any doubt? Ask me. Anybody any doubt? Ask me. Anybody? So basically what I'm doing is, I'm doing same pattern, lot of question. That is the formula. If you do just one pattern, one question, you won't remember. I'm making you do so many question in the same pattern, means your brain will recognize, okay, this is what it happens, this is what we need to do. Okay, so next time you get the question, you will understand, okay, while loop I need to run. If you have to iterate each and every number, while loop. If you have to iterate from 1 to that number, it is using for loop. Tell me, clear everyone? Thumbs up if you are clear. Everyone, thumbs up if you are clear. If any doubt, ask me. If anybody any doubt, ask me. So I request you all to do today's all this question once practice. If you are not practicing, it will go in vain. I'm telling you, everything go waste. Everything will go waste if you are not practicing it once. I can tell you for sure I am today here just because I practiced all those questions, just because I practiced. Even if you can put a headphone, just code it once, without looking at it. Just try to put pressure in your brain and try to code it without looking at it. That's how you get the confidence. The confidence, real confidence comes from there. Real confidence just is not understanding. You understand, but you do it with your hands so that you make it more clear. Okay, now I don't have to remember all this question, I just can do. Why? Because I've done enough of question, I've done practice enough of question. All this understanding, it's all about practice. Okay, so are you done? Tell me yes or no. All this question we are done. All this question we are done. Yes. All right then. That's it for today's class. Everybody listen, we'll not be having class on Saturday and Sunday, so you enjoy your weekend. At the same time, make sure you practice it. Okay, just 20 questions are there. Make sure everyone can do all the questions. If I ask you any question, make sure you can do 20 questions. By confidently you can do. There should not be any doubt on all these 20 questions. Am I clear? Tell me yes or no. This, just make sure this weekends you practice 20, all the 20 questions. Okay, you practice twice, thrice, whatever times it takes, but make sure you are practicing all the 20 questions again and again. Okay, done everyone? Just thumbs up once again so that I know everyone is clear. Okay, all right, if you are done, if you are clear, that's it. The will end the class. Make sure you no class in weekend. Practice, make sure you practice. Okay, anybody any doubt, you ask me in the group. I'm always there, and whenever you are having any doubt, go and watch the recording once again. That's why I'm sharing you the recordings. Okay, that's it everybody. Then we'll pack it up. Yes, have a great night. Yes, bye bye everyone, good night.